So what has happened is obviously a lot of sanctions have been placed over the years, right, to not allow US technology to be provided, all the cutting edge technology to be provided to China.
India, in this context, when you think of it, right, is an interesting juncture. Both, I would say, from the point of view of the positive, is of course, given the good relation it has with the US, and so that sense it's sort of favorable. They've committed what almost $18 odd billion to position ourselves as a semiconductor hub as well. Tell us what that means for India, and how do you compare, our strengths and weaknesses compared to, let's say, China, Taiwan, US, etc. in this context.
I think with the current focus now from the government with the Indian semiconductor mission and then the semiconductor funds, right, that has been put in. I think again it's a start, but it's better late than never.
Hello, everyone. Welcome to Manufacturing Mindset. I'm Sarvesh Kanodia, and I'm glad to introduce you to Mr. Abhay Singh, who leads Silicon Partnerships and Operations at Google. He's based out of Bay Area. In this podcast, we'll talk about all things related to semiconductors. As background, Abhay and I also went to school together. So, Abhay, welcome to our show, Manufacturing Mindset.
Hey Sarvesh, thank you for having me here. It's a pleasure to be on your channel. I've been a viewer of your work in this podcast, and obviously we went back to school together. So really happy to be here with you.
Super. So, Abhay, tell us about your journey, post your graduation in India. And of course, there's a lot of talk about it right now, especially on the immigration side. So, what were some of the biggest challenges that you faced when you were in college, and also the first job after college, and how did you tackle those?
Yeah, sure, Sarvesh. So I guess if we take path uh, down the history, right? So I moved here after college from 2005 to 2009. So after schooling together in Calcutta, then I went to BITS Pilani. So that's where I did my undergrad in electronics. And then I would say again, BITS Pilani was kind of the starting point of getting me into interested in semiconductor and digital design and designing chips. So I think in the third year we had this very popular course on electronics. And then when I moved to US, again it was for my masters. So I applied to a few universities, and then I decided to join Purdue. That's where I did my master's in computer engineering. And then since then, again, I've been in the last 15 years, my career has been in silicon and semiconductor. So to your question, again, I think over the last 15 years, obviously with the US immigration and with kind of, I would say, geopolitics, things have been, I would say, at different times in the career has been changing. And then particularly now, as we have been hearing in the news related to kind of with the new administration, the challenges around visa, even for students. So I would say in my years, it was not as challenging as what we are seeing currently. I think I would say again, looking backward, you can always think of how things fell in place, how there's always luck involved, but at the same time, there's always a challenge as an immigrant coming into a new country, changing visas and getting jobs. But I would say again to the audience is always look for consistency, right? You cannot let any challenge define you. You have to come up with how you resolve yourself to then move forward and keep trying. So I think that's kind of been my journey as well, where if I look back, there have been multiple times when I would think that, okay, I have not been able to do something I wanted to do, but then you still keep trying, and then in the next try you get forward. Um, so yeah, I think that's kind of the journey thus far.
Of course, that's very well put. And tell me about, apart from immigration, of course, but like, what was that one big challenge in getting a job there, or whilst, sort of doing your college there, as someone who came from outside, be it adjusting to the culture, and, talk a little bit about that and how that shaped you in your later years as well.
Yeah, anyways, so I guess looking backward, I would say that again, you can always look at steps, and then you find that you either find. I guess for me, I would say coming from a university like BITS, I was in fact quite lucky that there were a lot of seniors, a lot of people from the universities in the industry or in Bay Area when I first moved. So in I think that I would say was a part where I feel fortunate. Again, from a challenge perspective, getting the right like the visa lottery, like the H-1B is a process where you never are, even though you have the job, you apply for it, but you always have to go through a lottery. So that you have to overcome in terms of just getting selected in the lottery. But again, apart from that, from again, you have to just be consistent with what your passion is. Make sure that you continue kind of doing, uh, even though you don't get something in the first try. And that's, I would say, when I look back, even getting into uh, I started my career into engineering, and then I wanted to pivot and go into more understanding from a business perspective how partnerships and silicon is created in the ecosystem. So, at that point, I think it was my management at Cisco then who kind of supported me to go do executive MBA, and then that helped me pivot into my career where I am currently. So again, I would not uh, call it in terms of overcoming challenge, but it's just as you say, right? Being consistent with what you want to achieve and keep trying in terms of making sure that you come up with solutions on reaching that path is how you overcome it.
Super. So consistency is the key word, basically.
Yeah,
Yeah,
definitely.
yeah. And let's, before we go into semiconductor, I just want to set background for everyone who's listening to this, is about your prior role as well, right? You've, of course, worked at Nvidia, prior to joining Google. You worked at Cisco as well. So tell us a little bit about that engineering journey.
Yeah, definitely, Sarvesh. So maybe I'll just start by explaining what currently at Google I'm working on. So again, Google is well known as a software company, but in the last 5 7 years, I think what Google has also been doing is part of the Google Cloud. So a lot of the services and infrastructure that Google runs on is supported by the hardware that Google builds itself, both to support the cloud customer as well as to support its own infrastructure, right? And a lot of the, I would say, the innovation that is driving both the performance of how the infrastructure is being run is comes from the silicon. So as part of the role that I am currently in Google Cloud, I and my team, we look at overall from a silicon perspective, what is the right strategy, what is the partnership that enables Google to achieve the kind of the need of this infrastructure and cloud hardware. And then prior to that at Google, I think people know about the Google Pixel phone. So even the Pixel phone is differentiated by the silicon that Google designs, which is the Google Tensor silicon. And I worked on that silicon for a couple of years. And then prior to that, as you mentioned, I spent a few years at Nvidia, and then about 10 years at Cisco, also in silicon, looking at Cisco networking in data center and enterprise from a silicon perspective.
So you've been doing silicon all your life, and Google, what we all think is just a software company. There's a lot of hardware at the back end as well.
Correct, correct. I think again, all the applications, all the, I would say, services that Google is providing is enabled by the Google infrastructure and the Google Cloud hardware that is built on various types of silicon, both in compute, networking, and then GPUs that are enabling the AI workload for Google.
Super. So that sets the stage for our discussion on semiconductor. Let's start at a very high level, right? Like everyone is, of course, talking about this industry. We've all realized how important is it. Tell us about how large this sector globally is and actually how it is impacting us as an individual.
Yeah, so semiconductor industry, if we look at a macro level, right, it's I think at this point it's probably in the 600 billion range of total revenue a year, and it's been growing. I think the last few years post COVID, we really saw a uptick in terms of the year-over-year growth. And then one way I think for the audience to look at the industry would be to kind of segment it from the application point of view, right? So if I look at the overall industry and then where all semiconductor chips are being used, so you can think of any wireless communication where you have chips supporting your your Wi-Fi, your 5G now, and then the next gen protocols, right? Then you have your computer application, which is kind of it starts from the laptop, your CPUs, and you have personal computers, you have GPUs on the laptop, right? So that's kind of your computer application market. Then obviously in the consumer electronics, you have your phones, you have audio, gaming device, right? So that's a big segment of the industry. And then there is a lot of electronics that is now going into automotive, right? Like, yeah, automotive always had electronics, but I think as we go currently with the electric vehicles and all the latest feature that is being enabled, it's almost like a computer running on a car. So that itself has a lot of electronics going in. So, so I think with this view, then you can see that how the total 600 billion that I said, and then going forward, I think it's expected to hit about a trillion by 2030, right? So those are the different applications that is being enabled by innovation in the silicon or being enabled by servicing through the silicon.
Super. So this industry, one, is all around us, irrespective of whether we realize what's happening at the back end or not. And secondly, it's as large as GDP of several large countries as well, just to get the magnitude of the size, right? So just given the impact it has on the economy, obviously it makes everyone curious, right? So if you were to explain, behind the technicality of it to a 10-year-old, how do you describe the semiconductor ecosystem, right? Because there's a lot of evolution when it comes to getting that semiconductor made as well, right? So, what are the key parts of value chain? How should one understand the sector?
Yeah, yeah, sure, no, I think it's it's a challenging. I would say that in the sense that semiconductor as a manufacturing industry, it's one of the most complicated setup that there could be, right? In terms of how it is designed, just in terms of the ecosystem that is needed, and then also the kind of instrument and machine that is needed. So let me try to break it down so that we can talk to the different aspect of it. So again, it all starts from, so to speak, sand, right? So that's where the silicon that we talk about it comes from, sand, which is then built into a wafer, right? So maybe I'll kind of talk through it in terms of different aspect of the cycle, right? So there is the cycle which is the design part of design, like silicon, and then there's a manufacturing cycle, right? So in the design cycle, then you have elements around what is the product level requirement that is driving what silicon you want to build, right? So in that product requirement, then based on the product requirement, it gets broken down into what kind of IPs or what kind of features, right, that has to be built in. And as part of that, then there are companies like AMD, Nvidia, Qualcomm, right, which are traditional chip companies. So they're kind of the whole business model is designing chips. And then there are companies like Google, Apple, Amazon, right, which are product companies, but then they also have a lot of requirement of different kind of silicon, right? So in that ecosystem of designing, there is a lot of partnership that happens where the product companies might partner with a chip company, right, to be able to give them the features that they want, and then they will design it. And then in the same aspect of IP and design, there are a lot of IP companies that we hear about. I think ARM as a CPU IP, then Synopsys and Cadence that provides a bunch of other IPs, right? So it's an ecosystem where each partner is trying to kind of develop something that they can then replicate across different industry and different application, right? So that's the design part of it. Again, I've given a very high level overview. There are a lot more that goes into just the aspect of
Of
designing
course.
art form. And then if I
Yeah.
look at the second part, which is the manufacturing part, right? So that's where we talk about the fabs, right? Like TSMC and Intel and Samsung, which are currently the top three fab companies. And then and then outside after the fabbing
And
of
explain
silicon.
fab.
Sure. So fab is where the silicon raw material that goes in gets fabricated, so to speak, right? So once a company designs what it wants to be manufactured, then they send that design blueprint to the fab, which is TSMC or Samsung, and then that's where the manufacturing of the design happens in the form of a wafer, which is then broken down into die. So that's kind of the start of the manufacturing process. So from a design, the blueprint is sent to the manufacturing fab, so to speak, which is TSMC, and then that's where the manufacturing starts. And that's the first step, because then after the die is created, then you need to still package it so that it could have the different power points to be connected on a PCB, and then before that, then you need to test it. So those are the other aspect of manufacturing, which we call as OSAT, which is again testing and and then packaging of the die, right? And then again, there's a huge ecosystem of partners around that, because there is a lot of different kind of materials, different testing protocols, different test instrument that is needed to build that from the design to the final product. A lot of those steps happen in the manufacturing.
And one term we typically hear these days is also fabless companies. Explain to us what that means in this context of design and manufacturing, what those companies are doing.
Sure. So, yeah, so fabless comes from the fact that companies who don't own the fab. So that's why they call fabless. So as I was talking earlier, so we have this ecosystem of companies which are chip companies like Broadcom, Nvidia, AMD, right? So these companies, their whole business model is to design and sell chips, right? But they are not the one who are also operating the fab, because they are not owning the manufacturing side of it. They're only owning their design, and then the kind of getting the design built and then selling it to customer. Whereas on the other hand, there are companies like Intel, right, who also has products that they sell, and they also own the manufacturing of it. So they are like so they can be they are fab companies where, or they have their own fab. And then TSMC is one company which is kind of, I would say, one of the most important companies in the whole ecosystem, because they don't sell any product, right? They only service as a manufacturing partner to almost all the silicon companies, right? So, and then currently they are the one who has the technology to design the most cutting edge. We call it, in terms of the nanometer, or the lower than the nanometer, the more cutting edge it is. So they are currently the one who is designing the most innovative and most cutting edge fab technology, right? So yeah, so that's the kind of the distinction. So you have companies that don't own the fab, but still silicon companies, and they're called fabless.
Got it. Interesting. And you mentioned about Nvidia. You've also, of course, worked at Nvidia. Whenever we talk about the semiconductor ecosystem, it's obviously everyone talks about that company, right? Especially given the rise that they've seen. You worked inside it. So what brings them to such a unique position, and how have they managed to create this global dominance that they have in this space?
Yeah, Nvidia, I would say, is always even in the last few years, because of the whole revolution in AI, and the way their revenues and stocks multiplied, and has been in attention. But I think for a semiconductor professional, and for somebody studying semiconductor and being in silicon, Nvidia has always been that cornerstone company that has done kind of most innovative and challenging products, even back like 15 years back. So when I started my career, I think the first my first internship was at Nvidia. My first role was at Nvidia, and as I look through the product journey that Nvidia has taken, I think obviously it has found itself to be in some sense at the right place at the right time, with the multiple transitions that the industry has gone. But that also shows some of the vision of the Nvidia CEO Jensen, because he always had that vision in terms of creating the best product, but then also kind of having this software ecosystem, which is what is enabling a lot of the success that happened, right? So again, to give kind of the history around where the company started. So we look at in the laptop, right? Even in back in the days when we used to assemble our own desktop, we always had this GPU, which is the graphic processing unit, right? So that's the key product that Nvidia built, which was different than what Intel and the AMDs were building in terms of the CPU. So Nvidia found that by building this graphic processing unit, it was very good at running that graphic workload, which is how you kind of go through the pipeline to display kind of very good graphic, right, so to speak. And then over the years, Nvidia found that when machine learning started off right in the early 2010s, some of the use cases of running the machine learning load was already working out well with the GPU hardware. Whereas the industry outside of the GPU was trying to come up with other architecture that can still run it, and then I think Google then came up with the TPU architecture, and other companies went. But then Nvidia, with the GPU itself, they already had a blueprint that would run those application or those workloads better. So that what I would say that was the one trend that kind of was the tailwind for Nvidia. And then before that, even during the days when Bitcoin and mining was kind of getting popularized, even there was a kind of a benefit of running on those mining algorithms on the GPU. So that was the first kind of wave that Nvidia rode. Uh, but again, looking back at some of the cultural elements of how I felt Nvidia kind of is where it is always, I think, getting the right set of talents that Jensen hired, and then even I think he has a philosophy where even now he has a like organization structure which is kind of very flat, where maybe he has 50 people reporting directly to him. In other companies, you have all these big silos that gets created, right? Whereas he's still very close to what's happening across the business. And then I think with his passion and with his way of that vision that he has, he's continuing to invest. He did some good acquisition to diversify from just kind of the GPU for the laptop and the GPU market to data center by acquiring a few companies. And then I think now all of the data center companies like Google, Amazon, Meta are kind of the biggest revenue driver for Nvidia.
Interesting. You mentioned about the software ecosystem that they also created, right? Can you talk about that? And of course, in our podcast as well, we've always been talking about, even when you're talking about manufacturing, it's not just hardware, there's always a combination of hardware plus software when you talk about next gen technologies. In the specific case of NVIDIA, how did that sort of play out?
So with NVIDIA, I think what was created was this programming language called CUDA, right? So typically when you are programming for any hardware application, a lot of time, then I guess, I mean, in the beginning of the journey, right? Not many people were used to kind of working on a GPU. So what the CUDA allowed was it gave a lot of libraries, it gave a lot of kind of the base application for then developers to run on. So that kind of created an ecosystem in itself, where then a lot of engineers who was working on high performance compute or who were working on high performance graphics were used to running things using the CUDA library. And then those engineers, as they move around or as they worked on different application, they always started off with the baseline of the CUDA architecture. And then that's where I think Nvidia had kind of the leapfrog the competition, because with the competition they could not match up to having a similar level of library support and software support for their hardware. I think I know currently as a challenger, AMD is another company that also builds their own GPU, and that also has been in the both the CPU and the GPU market, right? But from the aspect of not having the same moat from a software perspective is what has been lagging for competition to catch up.
Interesting. And is AMD the next challenger to NVIDIA, or there's someone else in the fray as well?
Yeah, I would say I think right now it's obviously Nvidia is the leader in terms of the AI and graphics. Obviously, they have been doing it for long. So from a graphics perspective, again, AMD has always been there. In the AI space, I would say there are other challenges as well apart from AMD, because some of those architecture are changing so fast in terms of the requirement that AI is driving, right? You keep hearing about the models, the new model that is getting built, which is exceeding the number of kind of GPU that you need to train those models. So from that perspective, I would say the other challenges are also some of the cloud providers themselves, who instead of buying the GPUs for Nvidia are also thinking of their own silicon in terms of doing servicing those models and servicing the workloads for their application better. So I would again in that bucket of the other cloud providers, which is Amazon, Microsoft, Google. I think they are currently a sizable revenue for Nvidia, but then each of them are thinking of their own silicon strategy on how to do service their own workloads better.
Interesting. So you are saying the customers themselves might be the biggest threat to their dominance going forward. Could be.
Could be. I guess in the
Uh,
last couple of years, I think with them, if we break down Nvidia revenue, I think some of the top five customer would make 40 to 50% of the revenue, and each of those are looking at alternate structures, right? But again, it's still a ways to catch, and then Nvidia is also diversifying in terms of buying some of these companies that they did, providing application, and also building out different business model. I think with Omniverse or with robotics, I think they are enabling different use cases. But in the data center and cloud space, I think the challenges would be the customer themselves.
Interesting. And tell me something in the context of semiconductor and USA, of course, there's a China element to whatever is happening right now, right? And we saw recently as well how some of the export restrictions impacted, Nvidia and the stock. But that's a different thing. But more in terms of what's happening in terms of the geopolitics here, talk to us about the interplay and what do you think is happening there?
Yeah, no, definitely. I think that's the very aspect of semiconductor that got highlighted, I would say, during the COVID time, right? When the whole supply chain was affected, and then suddenly the companies, all the countries realized that so much of reliance on semiconductor manufacturing coming from Asia, right, was almost bringing all these countries to a standstill in terms of not having access to the technology, both in terms of their industry, as we talked about, as well as a lot of military application. Right? And then the second one is definitely China, right, which is the where with how the US as well as other industries are looking at from a access of technology perspective, with access to semiconductor is what will then allow both the AI training as well as a lot of use cases in defense and then so what has happened is obviously a lot of sanctions have been placed over the years, right, to not allow US technology to be provided, all the cutting edge technology to be provided to China, not only directly but also sanctions through machinery or sanctions through kind of reducing the reliance, right, of the semiconductor ecosystem to China. But then the fact is that obviously, as I talked about TSMC and the whole ecosystem of manufacturing, a lot of it is present in Asia, in Taiwan, in Korea, in Japan, right? So it's, I think the industry over the years has benefited and was built on kind of partnership and each part of the ecosystem. So, for example, US and India also, in some sense, was very focused on the design side of things, where a lot of people working in the design aspect are either in US or in India. But then both of them did not spend enough on the manufacturing. So there used to be, I think Intel was one of the fab, but even over the years, it has lost its dominance compared to TSMC. And then apart from Intel, not much manufacturing was happening in US. So I think now with COVID plus with some of the geopolitical tensions between the country, I think a lot of countries have realized that they need to become self-sustaining in terms of the silicon, right? So the geopolitics and then the financial implication of not having access to the semiconductor technology with respect to the product competitiveness, right? So that causes fluctuations in kind of those companies' stock and then from a technology perspective also, right? Understanding that as you have access to the most cutting edge silicon will allow your overall product to be more competitive, right? So I think all of those, what has caused is a lot of the investment happening in countries, right, to build up their own supply chain from a semiconductor manufacturing perspective. Obviously, China has also realized that it needs to build its own ecosystem. So their government has been investing a lot, and then same in US and Europe and other places as well.
And today, China would not have a TSMC equivalent or as large enough or close to that.
Correct, correct. I think they don't have anything close to the
Hmm,
innovation that TSMC has. But
hmm,
again, they have
hmm.
been, I think China started investing, or I would say almost 5, 7 to 10 years back, right? So they are coming up with a lot of, we hear a lot of news coming out where they have done few things which I think they did not have the capability for, maybe 5 years back. But they obviously they are still not as competitive as TSMC, but since they have the investment coming in, they have the focus, it would not be a surprise. And that's the reason why all the sanctions are being placed, because US is trying its best to be able to provide that kind of not have the access to all the technology that will allow the semiconductor market in China to flourish. Uh, but again, I think it will be a race, and then at some point, as the countries progress in terms of the focus and the investment, you might see them catching up.
Very interesting. And India, in this context, when you think of it, right, is an interesting juncture. Both, I would say, from the point of view of the positive, is of course, given the good relation it has with the US, and so that sense it's sort of favorable. Plus, there is a lot of push from the government. Although one could argue that when you look at it from a China perspective, they started investing sort of years, before us, and of course have put in a lot of money. But irrespective, I think it is a space where India is putting a lot of effort now. They've committed what almost 18 odd billion dollars to position ourselves as a semiconductor hub as well. Tell us what that means for India and how do you compare, our strengths and weaknesses compared to, let's say, China, Taiwan, US, etc. in this context.
Yeah, no, I would say that first of all, I was very happy when some of those initial news around kind of invigorating the semiconductor supply chain in India started, right? I think when I remember when I was coming out of college, hardly any or very few companies that you can count in your like one hand that were like pure Indian companies working on silicon and even from design perspective, right? But I think what has happened again over the years, as I was mentioning, India does have the people skills on the design side, where a lot of I think IITs and BITS and ISCs, right? There are a lot of research, a lot of professors working on that aspect of things where people have the knowledge around silicon and semiconductor design, right? I think what was lacking was the focus on the manufacturing aspect of it, right? Because that's where none of the investments are happening. I think with the current focus now from the government to with the Indian semiconductor mission and then the semiconductor funds, right, that has been put in, I think again it's a start, but it's better late than never, right? So I think with because what is also happening is that as the Indian economy, as the obviously the consumption of semiconductor in India is already I think more than 100 billion and it's continuing to keep growing. So I feel with that consumption, if the manufacturing in India can tap into that, I think that by itself will drive a lot of growth within India. And then obviously if it can stand up to support kind of a China plus one strategy or to support other countries in Asia as well as US, right? That would be an added kind of a benefit of building that ecosystem in India. So if I have to compare, obviously what India has done, and then with the announcement that Tata with the fab that they're building in Gujarat, the OSAT facility in Assam, right? With both of them, they have rightfully they have found a partner. Like in the case of the Tata Semiconductor fab, I think they are partnered with PSMC in Taiwan, so they will still leverage their technology because some of this building of the technology of designing is something that those companies have invested with very close partnership with academia over decades. So I think for India, we have the ecosystem with the research happening in the IITs and ISCs to create the impetus for the future development. But for I think in the current journey, by partnering with those companies is the right step forward. I feel. I think where India is ahead, I would say, is in terms of the design talent, in terms of talent of thinking of the application and then building the design for that application. So I think so on that respect, we have almost all of the companies, including the US companies, Google, Meta, Amazon, they have the design centers in India. There's a lot of talent is already there, right? Now, I think to think of from a problem statement of what applications need to be enabled for the for Indian customers and the Indian use cases, I think those can easily be done. But from the manufacturing side, I think it will still take time. I think what we have started now is still not the cutting edge. It's maybe 3, 4 generations behind to what the cutting edge is, right? But I think, as I say, it's better late than never. So I think with the start now, we have a lot of room to grow and to continue moving forward in the coming years.
And where do you see the opportunity given all of this, boom that is likely to happen? Where should entrepreneurs focus on?
Right. So again, I think there are, I would say, two aspects to the opportunity for India, right? So one is in terms of the ecosystem, what again for big companies like Tata and then a few other have done in terms of creating the facility for fab and OSAT. So I think OSAT, as I was mentioning in the beginning, are the facilities where you do the packaging and the testing. So that is the second level of the in the manufacturing cycle where there is not as heavily capex intensive as the fab. So that could be one opportunity where I think other partners or other companies can think of investment. Now, from a, I would say, as entrepreneur who is kind of maybe a startup or just trying to build a technology around the ecosystem, I think on that, I would say what India provides is with the market that we already have in India in terms of the different application and different use cases that can be benefited by silicon, right? So I think that's where the entrepreneurs needs to understand where by designing a new silicon can help accelerate the product competitiveness compared to buying something from China or other countries. And then by having the ecosystem of manufacturing now being enabled, it could create the whole end to end from a design to manufacturing to customers in India. That is what will accelerate, right? Because then you're already close to where your revenue will be generated. So that's one aspect. I think the second aspect also is even in the ecosystem of manufacturing, apart from the fab and OSAT, there are still other pieces around testing, around design services, around I would say skill-based training, right? That could be other opportunities for entrepreneurs or for companies to kind of take on and help create the ecosystem. Because I think if I talk about packaging, so there are things that is needed for packaging in terms of substrate or in terms of other materials that goes in. So there could be opportunities there for entrepreneurs to think from a manufacturing point of view what would be needed to enable that technology, right? In terms of testing, there are depending on the use cases, there are requirements across PCB or load boards or system level test equipment that needs to be designed and enabled. So the lab infrastructure for that or the testing facility for that could be another opportunity for entrepreneurs to work on.
Interesting. On the last one, I've been visiting some of the electronic assembly and testing facilities. You have that industry at least booming quite a bit in India over the last few years. And one of those things I notice is, of course, most of those machines are either German or the Japanese, Korean, etc., right? And some Chinese also. But like basically either some of the other Asian countries or of course Germany. So yes, if there's something that you can actually build out of India, that could be quite spectacular. But what you're saying is within the designing piece itself, the assembly piece itself, the material piece itself, or even like you're saying, so one of those things I see is it's also generating a lot of employment, right? And so if you can actually skill, the youth and get them to work in some of these factories, I think that by itself could be a meaningful piece as well.
Correct, correct. I think there are, again, as I say, it's an ecosystem that was built around the whole world, right? I think now with India, if they want to become self-sufficient from the whole, from design to the end, there's a lot that needs to happen within India, right? And then
mm,
that's where
mm.
all there are a lot of opportunities that would be there. So I think with the focus of investment coming in, and then with the fab there, so because that's the most critical element of the manufacturing cycle. Like it starts with the fab. So the fab already present. I think a lot of those, I would say, alternate or the subsequent steps could then be enabled within India.
And are there any interesting companies that you've sort of seen in India, who are sort of playing in this space?
So I guess from an Indian startup or an Indian company perspective, I know there are like as I say, a lot of US companies they have the design centers in India, right? So I think from that perspective, almost a
So
lot of
design we solved for basically in India. Now is the other pieces that essentially we need to solve for.
correct the
Net
manufacturing
net.
piece, and then
Mm,
and
mm,
then India focused application. Right? You got the
mm,
Googles and the Apples and the like Amazons of the world, right? They are creating the product for the whole globe.
mm,
Now,
mm,
in fact, again, I know for the if I look at India specific problems, right? Then there is obviously you think about pollution and you think of air purifier, right? So can there be an innovative air purifier created with using from some innovation from a silicon perspective or from a hardware perspective, right? That can allow that can create a better product. So that is one use case. Again, we look at like smart locks or like smart vision cameras, right? So again, there's a lot of demand that's going to drive in that application. So what kind of a technology from a silicon perspective can be created in India, right, to enable that market? So I think those are areas where there is again a lot of I mean, right now a lot of those is coming from other Asian countries, China specifically, right? So that application and that use case can be built in India now that we have the supply chain readiness going to happen. Um, and then even if outside of that, just the like the daily use electronics, like your television, your cell phone, right? All of those silicon is also currently not being designed and manufactured in India, right? Those are opportunities in the coming year because those are devices and use cases that we don't see any end in the near future, right? So it continue to grow, and as more and more people in India are getting access to internet and cell, right? So those consumer devices are continuing to grow, and each of them is powered by silicon. So being able to design those silicon end to end, I think I recently heard about like Xiaomi has a big presence in India, right? So with that, I think before they were not designing their own silicon, but they are also investing in building their own silicon to do kind of for their phone. So those kind of again application there will be numerous such applications where India can then think of designing their own silicon and then use the manufacturing uh, ecosystem that will be created to enable it.
got it. Super. I think, of course, this is a topic we can go on and on. But let's go wrap up with one final question. I'll go back to our discussion on US and everything else, right? Like in terms of there are of course many young people who want to move there. What is that one or two mistakes from your learnings that they should avoid?
Right. Yeah. So I say again for young people who are looking for US for maybe higher studies or for work opportunities, I think I would say particularly for a silicon perspective, I think that right now what is happening in the ecosystem for semiconductor in India is a great place to be in terms of the trajectory that will happen. So again, back when I went out of college and looking into, I think there was no such opportunity back there. So then the only step was to then go forward and kind of come to US. But I would say that people should really think about with the next 5-10 years in India trajectory that can happen. So definitely think about that. I would say, and then with all the issues around visa and immigration that we have been hearing in the recently, I would also say again, I have gone through my journey, right? Where looking back, there were things that fell into place. But one advice that has always held true, and even for me when I was thinking about it, held true was you should think of uh, again from an education perspective. Again, it's a top-notch education that you get in US universities, right? But you should always look at the ROI for your individual use case, right? So I would not really recommend somebody taking a huge loan and then trying to come and then think that they will make it work. So again, there are so many unknowns that it's not out of your control, right? So by taking that huge risk, then you kind of put yourself on a back foot in a lot of career choices or choices around various aspects of your life that you want to create. So I think the key mantra there would be that you should always think of going to a university or going for a line of education where you have a sight of how to get funding or how to get some sort of a scholarship or a sight of how do you fund your education, right? And not really depend on kind of your loan. And again, unless you already have that access, right, from your family perspective. But that I think that's very critical because then you can think of maybe working for a couple of years and then trying again to see that you should have a line of sight, either talking to other of your alums or other of your people that you know in the university, and have they found something, and then what are the opportunities in on campus to enable that. I think that's a very key. And when I look at my journey as well, I think in the first semester I did not get the scholarship, and then when I did get it in the second semester, I think there was a vast difference in terms of my thought process, in terms of the learning outcome, and then what I wanted to do based on not having the whole aspect of
Pressure.
pressure on it.
Yeah.
Yeah.
Yeah. Yeah.
So
Interesting. Yeah, so what you're saying is definitely explore, but do it in a way where it makes sense in terms of ROI, whether the course makes sense, the university makes sense. Don't just go because you're going out and so you'll be foreign educated. It won't matter unless you've chosen a good course, you've chosen a good college, and of course you've sort of managed to get the scholarship, etc. So that given the high fees, etc., it's not like the loan amount is becoming burdensome and affecting your productivity as well.
correct, correct. Yeah, I would definitely have people consider that rather than just applying and going and just to come here. Yeah.
Super. Thank you, Abhay. We've covered a fair ground both on semiconductors and immigration as well. Really appreciate you taking out time for us.
Yeah, no, Sarvesh, as I said, it's a pleasure to be here. I'm a viewer of your channel, and then I'm think you're doing a great service to the ecosystem by kind of talking through different manufacturing use cases. My dad is in manufacturing. He has been in manufacturing for 40 years plus, right? So I really see the knowledge that you're bringing in for enabling the next set of entrepreneurs in manufacturing. That's a great work that you're doing.
Super. Thank you so much.
Thank you, Sarvesh.